students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So today we are going to discuss part 3 of the chapter Equilibrium, where we'll be talking about the topics Le-Chatelier principle and acids, bases and salts. Okay, so we'll also be doing some previous year questions, and one more information, please join our WhatsApp channel. Link is there in the description section. This will help you to get access to our notes, like PDF notes, mock test and solutions. Okay, so let's get started here. So you know, we have already done with part 1 and part 2, right, in which we have discussed about these things. In today's lecture we are going to discuss about factors affecting equilibria, ionic equilibrium in solution, and acids, bases and salts. Okay, we'll just going towards the introduction part of ionic equilibrium, and in the next lecture we are going to cover the most important topic, that is the ionization constant, ionizations of acids and bases, buffer capacity of solutions and the solubility product. Okay, so let us start with today's lecture, and weightage, you know, 1 to 2 questions you can easily expect from this particular chapter. So chemical equilibrium is much more important in this particular chapter. Now coming to today's lectures, we have these things. So factors affecting ionic equilibrium, factors affecting equilibria, ionic equilibrium in the solution, and acids, bases and salts. Okay, this one I'll be covering in the next lecture. Okay, now let us talk about Le-Chatelier principle. Very important concept. Okay, very important thing which is asked in the exam repeatedly. The Le-Chatelier principle says that it states that a change in any of the factors that determine the equilibrium condition of a system will cause the system to change in such a manner so as to reduce or counteract the effect of the change. Now I know you will not understand anything in this statement, so we will come back to the statement later. Okay, first we will understand what is, let us go into deep of this. The statement says that suppose you have any reaction you have any reaction where A is in equilibrium with B. Okay, if you are changing something to disturb this equilibrium, okay, how can you disturb the equilibrium, or what are the things that you can change to disturb an equilibrium? So first thing is you can change the concentration, temperature, okay, volume, pressure, right? These are the main 4 things with which you can change the equilibrium. So if you are trying to disturb the equilibrium, how can you disturb the equilibrium? By changing the concentration, temperature, pressure or volume. Okay, so if you are changing or if you are disturbing the equilibrium, then the reaction will shift in such a way. Reaction has 2 options to shift. Where the reaction can shift? The reaction can shift in either forward direction or in the backward direction. Okay, once again let us understand. If you are disturbing the equilibrium, how will you disturb? By changing the temperature, concentration, pressure and volume. Then the reaction will shift. How the reaction can shift? Either in the forward direction or in the backward direction. Reaction will shift in such a way to counteract the disturbance that you have introduced. Now this is what is the meaning of the last part. See, for the first part is if you disturb the equilibrium. Okay, if you disturb, one second. Okay, the first part is if you disturb the equilibrium. How can you disturb? You can disturb the equilibrium by pressure, volume, concentration and temperature. If you disturb these equilibrium, then the reaction will shift. Okay, reaction will shift in which 2 directions? Forward and backward. Okay, how will it shift? Reaction will shift in forward or backward direction to counteract the disturbance, or I can write to counteract the change. Now suppose, for example, you have disturbed the concentration by increasing the concentration, then the reaction will shift in such a way to decrease the concentration. It will act opposite to what you have introduced. For example, if you have decreased the concentration, reaction will shift in such a way to increase the concentration. So for example, if you have decreased the pressure, reaction will try to shift in such a way to increase the pressure. If you have decreased the volume, reaction will try to increase the volume. I am hoping that you are understanding the meaning of Lee-Chatelier principle. It states that suppose a reaction is in equilibrium, you are trying to disturb that equilibrium. There are 4 ways how you can disturb the equilibrium: pressure, volume, concentration and temperature. Now whatever change, whatever disturbance you have given to the reaction, in response to that the reaction will shift either in forward direction or in backward direction to counteract the change that you have introduced, or to counteract the disturbance that you have introduced. Suppose you have increased the concentration, the reaction will shift either in forward or in backward to decrease the concentration. Clear? That is what is Lee-Chatelier principle. Now let us see the effects. So I told you there are 4 major factors: concentration, temperature, pressure and volume. Okay, so now let us see the effect of concentration. So now suppose I have a reaction A plus B, okay, is giving C. This is a reaction. Now what is the change I did or disturbance I introduced here is, change or in disturbance that I introduced is I have increased the concentration of A. Okay, then what will be the response? How the reaction will try to, what the reaction will try to do? The reaction will try to, decrease the concentration of A, right? So that means what will be the shift, forward or backward? See, I have written in 3 ways. Suppose the concentration of A you have increased, the reaction was already at equilibrium, you added some more A to the reaction. What will the response of the reaction? The reaction will try to decrease the concentration of A, right? Reaction will try to decrease the concentration of A. Now to decrease the concentration of A, which direction it should shift, whether it go in forward direction or it should go in the backward direction. Now see, if reaction goes in the forward direction, what will happen? Whatever A you have added, that A will be consumed, right? That concentration of A will be consumed. So A concentration will decrease. What you have added some extra A and reaction is shifting in forward direction, that A will be used up, concentration of A will decrease till it reaches the original value, right? So in which direction in this case the reaction will shift? The reaction will shift in forward direction, right? Let us take one more example. If you have, for example, if you have decreased the concentration of C, okay, let me write it in 3 columns like this. First is what is the change that we have introduced, okay, next what will be the response, okay, next which side it will be shifting. Okay, now see, suppose I have decreased the, we'll talk about C, right? So let the disturbance is you have increased the concentration of C, okay, you have increased the concentration of C. The reaction was already at equilibrium, you added some more C to that. Then what will be the response? The reaction will try to decrease C, right? Now you think, if forward reaction is, our target is to decrease the concentration of C. Now if the reaction goes in forward direction, more C will produce, right? The C concentration will not decrease. But if the reaction goes in backward direction, then what will happen? Concentration of C will decrease, concentration of A and B will increase, right? So concentration of C decreasing is our target. So in which direction the reaction will shift? The reaction will shift in backward direction. Okay, so I hope this concentration game is clear to you. So what is the thing? If, okay, so if you are like increasing the concentration of the reactant, then if you are increasing the concentration of the reactant, reaction goes in forward direction, okay, and if you increase the concentration of the product, reaction goes in the backward direction. I'll give you the summary of that, but you should not remember it, you should try to understand it. Clear? Next we will go to the next factor, that is temperature. Okay, so temperature I'll be telling you very simple. We have 2 cases here, one is endothermic, okay, and another is exothermic. Okay, now for endothermic reaction, if you increase the temperature, reaction will go in forward direction, and if you decrease the temperature, reaction will go in backward direction. Okay, very simple. And in exothermic, if you decrease the temperature, reaction will go in forward direction, and if you increase the temperature, reaction will go in backward direction. You just have to remember any one, the other will be opposite to that, right? Just you have to remember one thing. For endothermic, if you increase the temperature, it is forward reaction. For exothermic, if you decrease the temperature, it is forward reaction. Clear? Next, we'll go to the next factor, that is pressure. Okay, this is very important and easy. So now see, suppose we have a reaction N2 plus 3H2, okay, gives 2NH3. Okay, so these all are gas. Right? Now what I can do, we have an option like this. What is the change? Okay, what is the response? Change, response, and then what is the effect? Okay, what is the change, response, and effect? Now see, here you should know one thing, pressure is proportional to number of moles. Okay, pressure is proportional to number of moles. Now suppose what you have done is you have increased the pressure. What will the reaction try to do? Reaction will try to decrease the pressure. To decrease the pressure, what it will go? It will go towards less number of moles. Decrease the pressure. Okay, it will go towards less number of moles because pressure is directly proportional to number of moles. If number of moles is less, pressure will also be less. So if you see in this reaction, this side we have 4 moles and this side we have 2 moles. I want to decrease the pressure. To decrease the pressure, I want to go towards less number of moles, and less number of moles is on the product side, right? So the reaction will go in the forward direction. Clear? Reaction will go in the forward direction. Now suppose I take another example here. Okay, let us consider the same example, or just a second. Yeah, let us consider one more example, that is H2 plus O2, okay, is giving you H2O. Okay, so here if you have, now this reaction we cannot consider because water is not produced in the gaseous state, right? So let us take this particular exam only, but if I take now pressure, I am decreasing. If you are decreasing the pressure, what will the response? The response will be to increase the pressure, okay, then it will be towards more number of moles, okay, towards more number of moles. Now if you see towards more number of moles means it is, which side more number of moles are there? We have 4, right, on the reactant side. So the reaction will be towards the reactants, and if it is towards the reactants, it is a backward reaction, right? So it is backward reaction. Clear this one? So pressure, if you have understood, volume is very simple. The same reaction if I take, okay. Now here you should know one thing, volume is inversely proportional to pressure. Okay, so if you are decreasing the volume, that means you are increasing the pressure, and if you are increasing the pressure, number of moles is increasing. Okay, so let us take the same example and we'll solve it like this. If I have H2, okay, plus how many? We have 3H2 plus N2, okay, is giving me 2NH3. Okay, we'll take one more reaction, that is your, I remembered another reaction. Let us take with a different example. N2 plus O2, okay, gives 2NO. Suppose this is the reaction. N2 plus O2 gives you 2NO, all are gas. Okay. Now suppose what you have done here is, let me bifurcate this one. Okay. So, or we can erase this part. We don't need this part. We already understood that, right? Fine. So now suppose what we have done here is change that we have introduced, change, okay. Next we have response, and then we have shift. Okay, so now see, what I have done is, in the change I have decreased the volume. Okay, so when you are decreasing the volume or increasing the pressure, it is of the whole system. Okay, you are decreasing the volume of the whole system. If volume is decreased, that means what? pressure is increased, right? Volume is decreased, that means pressure is increased. If volume is decreased, response will be what? Volume should increase, or I can say pressure should decrease, right? And if I want to decrease the pressure, okay, if I want to decrease the pressure, then reaction will go towards less number of moles, right? But here if I see that their number of moles are equal, okay, okay, so I can take another reaction. Sorry for this. I'll tell you what happens when there is equal number of moles also, but let us take the same example. I'm not recalling any other example right now, okay. So if I have this one, okay, so we have here 4 moles and here we have 2 moles, right? So now see, if you have decreased the volume, that means you have increased the pressure. If you have decreased the volume, response will be to increase the volume. To increase the volume, that means decreasing of pressure. So if I want to decrease the pressure, I have to go towards the product side, so the reaction will shift in forward direction, right? Clear this one? Okay, let us see the next example. That is, okay, you have something that is addition of inert gas, okay. I'll be summarizing all this, you do not have to worry at all, so please just understand what I'm saying. One more thing I just left here, okay, I'll discuss that later. Inert gas addition at constant volume and constant pressure. So here you should remember, if you're adding any inert gas at constant volume, then there is no effect on the reaction, okay. But if you are adding any inert gas at constant pressure, okay, so what happens here, when you are adding anything at constant pressure, to maintain that constant pressure, volume increases, okay. When you were, so suppose a system is there, okay, and you have added some extra inert gas to that, okay, and you want to maintain the constant pressure. So if you see, we have this equation, right? If I want constant pressure, like this is PV equal to nRT, right? So if you want constant pressure, then volume should also increase, right? So if you are adding any inert gas to maintain that constant pressure, the volume should increase, okay. Now if volume is increasing, what will be the response here? Response will be to decrease the volume, and if I want to decrease the volume, that is equivalent to increasing of pressure. That means it will go towards more number of moles, okay. So just now you have to understand, to maintain constant pressure, you need to volume increase. If you increase the volume, the response of the reaction will be to decrease the volume. To decrease the volume, that means to increase the pressure, and to increase the pressure, it will go towards more number of moles, okay. Now here a question may arise, that what if the number of gas molecules on both sides are same? For example, just as I took one reaction here, N2 plus O2 gives 2NO, right? In such type of reactions where the number of gaseous molecules on the reactant side is equal to product side, okay, in such type of reactions, what I can say, that the pressure and volume has no effect, okay. So this is pressure and volume has no effect, in which case if the number of moles of the reactant and product is same, okay. Clear? So now inert gas addition is also same, understood. At constant volume there is no effect, at constant pressure it will go towards more number of moles, okay. Next, what is the effect of catalyst? Effect of catalyst also no effect, okay, it doesn't change anything. Catalyst also, you should remember, it has no effect, okay. Clear? Now let us summarize that. First factor that we have studied is concentration, okay. So for concentration, what I want to say, if reactant concentration is increased, reaction will go in forward direction, okay. If product concentration is increased, reaction will go in backward direction. The rest is reversed. If reactant concentration is decreased, then it will go in backward direction. If product concentration is decreased, then it will go in forward direction. Okay, this is about concentration. Next is your factor is temperature, right? For temperature you should know we have two things, that is you have endothermic and exothermic. Okay, now for endothermic, if temperature increases then it is forward reaction, and if temperature decreases then it is backward reaction. Okay, clear this one. Next, third one is pressure. Okay, if pressure is decreased, okay, then reaction will go towards more number of moles. Okay, if pressure is decreased, reaction will try to increase the pressure. To increase the pressure, it will go towards more number of moles. Next, if pressure is increased, right, reaction will try to decrease the pressure. To decrease the pressure, it will go towards less number of moles. Okay, now talking about the fourth factor, that is your volume. Okay, for volume, if volume is increased, right, that means what, pressure is decreased, reaction will try to increase the pressure. To increase the pressure, it will go towards more number of moles. Okay, and if volume is decreased, volume is decreased means pressure is increased, reaction will try to decrease the pressure, and to decrease the pressure, it will go towards less number of moles. Okay, clear? And next, the fifth one is inert gas addition. For inert gas addition, you have two cases, right? One is at constant volume and another is at constant pressure. Okay, now if it is at constant volume, then there is no change. Okay, and if it is at constant pressure, that means it will go towards more number of moles. This is the fifth one. And the next one, that is sixth one, is addition of catalyst. Okay, catalyst, and that is very easy, you have to just remember it has no effect. Okay, and in pressure, one more case, if the number of moles on the reactant side is equal to number of moles on product side, okay, then also it has no effect. Okay, so this is the complete summary of your Le-Chatelier principle. Okay, you have seen, once again let us revise. Concentration, if you are increasing the reactant concentration, forward direction, decreasing the reactant concentration, backward reaction, increasing the product concentration, backward reaction, decreasing the product concentration, forward reaction. Endothermic, temperature increased, forward direction. Exothermic, temperature decreased, forward, sorry, here one small mistake. Exothermic, temperature decreased, forward reaction. Okay, next, coming to pressure, if you are decreasing the pressure, right, reaction will try to increase the pressure, it will go towards more number of moles. Increasing the pressure, reaction will try to decrease the pressure and will go towards less number of moles. Okay, volume, increasing volume, more number of moles, decreasing volume, less number of moles. Okay, next, inert gas addition, for your at constant volume, no effect, at constant pressure, towards more number of moles, right? Volume increases, pressure decreases, reactions try to increase the pressure, and that is why it will go towards more number of moles. Catalyst, no effect. Okay, fine. Now we'll go towards ionic equilibrium. Okay, so ionic equilibrium is the equilibrium between the reactions where ions are considered. Okay, so for example, if I have a reaction like this, Fe2 plus SCN minus gives FeSCN2 plus. Okay, suppose such reactions are there where you have only ions involved and there is an equilibrium between them, that is called as ionic equilibrium. right? So under ionic equilibrium we have two types of solutions, okay? One is your electrolyte solutions and another is non-electrolyte solutions, okay? Now what is electrolyte solutions? Electrolyte solutions means it is having ions, okay, contain ions. On what is another factor? It is a conductor of electricity, okay? And when you talk about non-electrolytes, they do not have ions, right? They do not have ions. And next is don't conduct electricity, okay? They do not have ions and they do not conduct electricity. This is clear. Now coming to electrolytes can be of two, like here first let us give an example of electrolyte is NaCl solution, okay? And non-electrolytes is sugar solution, okay? Sugar solution cannot conduct electricity because it doesn't have ions, whereas NaCl solution can conduct electricity because when you put NaCl in water, it gets dissociated to give you Na plus and Cl minus ions, right? Okay. Next coming to strong electrolytes and weak electrolytes. Strong electrolytes are those electrolytes which dissociates completely, okay? Which dissociates completely, okay? Means if you have taken 100%, like you have taken NaCl, all there will be in the solution, there will be no NaCl, there will be only Na plus ions and Cl minus ions, okay? All total NaCl has decomposed to give you ions. But weak electrolytes means which do not dissociate completely, which do not dissociate completely, okay? Which do not dissociate completely. Now what is the meaning of this? For example, you took CH3COOH, okay, and you dissolve it in water. So you will find that there are only certain amounts of CH3COO minus, there is H plus, and there is also undissociated CH3COOH, right? So those type of electrolytes which do not undergo complete dissociation are called as weak electrolytes, and which dissociate completely is called as strong electrolytes. Clear? So now understood what is solutions can be of two types, electrolytes and non-electrolytes. Electrolytes are those which contain ions which conduct electricity, example is NaCl solution. Non-electrolytes are those which do not have ions, they do not conduct electricity, example is sugar solution. Then under electrolytes we have strong electrolytes and weak electrolytes, okay? So now what are other examples of electrolytes? We have three categories. One is your acids, okay? Electrolytes can be acids, bases and salts, okay? So we'll be studying these three in detail, okay? The next lecture will be completely based on this, okay? Fine. Now we'll go to the definition of acids, bases and salts. You know, you might be saying that, ma'am, this we know from class 10, we have a chapter on acids and bases, right? But we will go little advanced from that, okay? The first is your Arrhenius. So there were three scientists who gave you the definition of acids, bases and acids and bases, okay? So the first definition was given by Arrhenius. According to Arrhenius, what was an acid? See, acid is something which can donate H plus, okay? So acid is something which can donate H plus, and base is something which can donate OH minus, okay? This was very simple definition of Arrhenius acids and bases. Example, you might be knowing many things like HCl, H2SO4, okay? And here you have NaOH, you have KOH, okay? Clear? This was there. Next, what happened? There were certain bases which were found, okay, but they were actually not able, they do not have OH minus, but they have basic properties, okay? So to help you with this, we have the next concept, that is Bronsted, okay? Bronsted was the scientist who gave the next concept about acids and bases. So what was told by him? So according to him, what are acids and what are bases? Okay, so acids is same, that is which can donate H plus, okay, and bases he changed, that is which can accept H plus, okay, which can accept H plus. Now let us understand an example from here. For example, if I dissolve HCl in water, okay, so what I'll get, H plus and Cl minus we will get, right? H plus will be taken up by water and I'll get here Cl minus and H3O plus, right? Now let us see this, very very important here. Now see, what is happening from HCl to Cl minus? HCl to Cl minus, there is a loss of proton, so HCl is losing a hydrogen or it is donating a hydrogen, so this one will be called as an acid, right? Now if you see here from H2O to H3O plus, right, what has happened? H2O to H3O plus, H2O has accepted one hydrogen. Which hydrogen was lost by HCl? That hydrogen was accepted by water, right, to give you H3O plus. So what is this H2O here? This H2O is the base. Why? Because it is accepting the proton. Clear? Now there is something about this Cl minus and H3O plus. Now see, the product which is formed after the removal of H plus, okay, this is acid, this is called as conjugate base, okay. So wait one second, we'll write it little bigger so that we can get more space and understand it clearly. So I'll write it once again. So if I have HCl, okay, plus water, and that gives you Cl minus plus H3O plus, okay. As I told you, from HCl to Cl minus, what has happened? There is a loss of proton, and because there is a loss of proton, this is an acid, right. Now if you see from H2O to H3O plus, okay, there is an acceptance of proton. If there is an acceptance of proton, this is called as base, right, this is the base. Now if you see HCl to Cl minus, this has lost an proton, so this is an acid, but we have a special name for this one also. This is called as conjugate base, conjugate base, okay. Now you see, if I say that if Cl minus can take one H from here and can become HCl, right, because it has the capacity to accept an proton from here and giving you HCl, so that is called as a base because it is accepting a proton, so that is why its name is conjugate base. Now similarly, H3O plus can lose one hydrogen and give to HCl, it can lose one hydrogen to give you H2O, so because it is losing one hydrogen, this is called as conjugate acid. Clear? These names might be new for you, but you should remember, anything which loses one H plus is an acid, but after losing H plus, what is formed is conjugate base. Anything which can accept an H plus is a base, but after accepting H plus, what is formed is called as conjugate acid, okay. So now basically what is this conjugate acid and base pair? So conjugate acid base pair differs by only one proton, differs by only one proton. Now if you see, HCl and Cl minus are a conjugate acid base pair, right, these are a conjugate acid base pair, and what is the difference between them? They have one proton difference. Similarly, if you check here, conjugate acid pair H2O and H3O plus, what is the difference between them? You have one H plus difference is there, right. So that is all about conjugate acid base pair. Clear? Now let us take one more example. Okay, let us take one more example here to understand it in a better way. I'll go to the next slide and I'll discuss here. Suppose I have NH3, okay, one second. Okay, so if I have NH3, okay, plus water, what will happen here? Here water can lose one H plus and give it to NH3, so we get NH4 plus and OH minus, okay. So now let us find the acid base pair here. Now you see what is NH3 doing? NH3 is accepting a proton, right? NH3 to NH4 plus, what has happened? It has accepted a proton. If it is an accepting a proton, then what it will be? It will be a base, right? Now if I see from H2O to OH minus, okay, H2O to OH minus, there is a loss of water, right? There is a loss of hydrogen. So H2O is losing a hydrogen. So if it is losing an hydrogen, it will be becoming as a acid, okay. Now I told you if there is a base, the product formed after accepting one hydrogen is called as conjugate base, right? This will be called as conjugate base. This is conjugate base. And one more thing, that is the product formed after accepting a proton, sorry, after losing a proton, right? This has lost a proton to give you OH minus. So this is your conjugate base. Conjugate base. Clear? Understood this one? Now if I tell, so what is the conjugate acid base pair? NH3 and NH4 plus, H2 and OH minus. Now if you see in the previous example, right, in the previous example water was a base, and in this example water is an acid. So when a substance can behave both as an acid and a base, we call it amphoteric substance, right? So that is why here I can write that H2O is amphoteric in nature, right? Why it is amphoteric? Because it can behave both as acid and base, okay, clear? Now how questions are asked from here. Now suppose there is a substance given, okay, and you want to find the conjugate acid of that, right? Please understand this one. Suppose you have been given with, so let me erase this part, okay, I'll write it here. Okay, so suppose we have, so what I have written here, H2O is amphoteric, and I know all of you might be knowing the meaning of amphoteric. Now suppose what I want to say here is, if you have to find conjugate acid of anything, the question is find the conjugate acid of anything, okay. So conjugate acid of anything if you want to find, right? So that means what you have to do, if you want to find the conjugate, sorry, so this was conjugate acid, right? Yeah. So if you want to find conjugate acid of anything, you have to add H plus. Remember this one. If you want to find conjugate acid of anything, you have to add H plus. You can see what is the difference here, base and conjugate acid, right? That is just the difference of plus H. You have added one H plus. So whenever you have to find the conjugate acid of any substance, you have to just add one H plus. And if you want to find conjugate base of anything, what you have to do? Remove H plus. This is very, very important. Please remember, questions are asked from here. Conjugate acid, then you have to add H plus, okay. Conjugate base, you have to remove H plus. You can see this example. If I want to find conjugate base, okay, conjugate base if I want to find, I am removing one H plus from here. If I want to find conjugate acid of anything, you have to add one H plus, okay. Conjugate acid if you have to find, add H plus. Conjugate base if you want to find, remove H plus. Okay, so till now we have two definitions. One is your Arrhenius concept, another is your Lewis concept, Bronsted concept. The third one is the Lewis concept. Okay, so according to Lewis, what is an acid and what is a base? Okay, so here he doesn't talk in terms of proton, he talks in terms of lone pair. So acid is something which can accept a lone pair, and base is something which can donate a lone pair. Okay, lone pair of electrons. Here examples are like BCl3, okay, and here example is NH3. Let us take one example. Suppose we have BCl3, okay, plus NH3. Now NH3 has lone pair, so that is why it can donate to this one, and we will get an abduct like this, that is BCl3NH3. Okay, so that is an example where acid means accepting of lone pair. So generally Lewis acids are those which are electron deficient, BCl3, BF3, right? And bases are something which are having lone pairs of electron, that is NH3. Okay, Clear this one? Okay. Now we can go and practice some questions. We have done a lot of concept today. So this was the homework question that I gave you in the last class, and I hope most of you have done it. Let us see. For the equilibrium CaCO3, CaO, CO2, Kp value is 1.64 atm at 1000 Kelvin. 50 gram of calcium carbonate in 10 liter closed vessel is heated to 1000 Kelvin. Percentage of CaCO3 that remains unreacted at equilibrium is. Okay. So if I have this reaction, that is CaCO3 is giving CaO plus CO2, right? This is solid, and this is gas. So now if I want to write the value, if you remember, Kp will be equal to, when it is pure solid we do not consider that, so Kp will be equal to pressure of CO2, and Kp value was given to me 1.64 atm, right? So pressure of CO2 is 1.64 atm. Now if I know the pressure, I know that volume, I know the temperature, I know the R value, then we can definitely find the N value, number of moles of calcium carbonate or number of moles of CO2, right? So I know PV is equal to nRT, right? So that means N is equal to PV by RT, right? So let me substitute this value. What is pressure? 1.64 atm, okay? Volume is 10 liter, then R value is 0.0821 and temperature is 1000. Okay. Now here if I just make it little simple for calculation, I'll make it 0.02 only, 0.82. Okay. Now if I see 10, 0 can get cancelled here. So this is 8.2 divided by 1.64. So I'll get 0.2, right? So I can say that number of moles of CO2 is 0.2 at equilibrium, right? So now if 0.2, so 1 mole of CaCO3 is giving you CO2, 1 mole of CO2, and before that let us calculate the number of moles of CaCO3. Number of moles of CaCO3 is given mass by molar mass, right? So 50 by 100 is 0.5, right? So calcium carbonate was 0.5 initially, and after the reaction we found that carbon dioxide is 0.2. Now 1 mole of calcium carbonate is giving you 1 mole of carbon dioxide. So if 0.2 moles of carbon dioxide is formed, that means 0.2 moles of calcium carbonate must have reacted, right? 1 mole of calcium carbonate is giving you 1 mole of carbon dioxide. If 0.2 moles of carbon dioxide is formed at equilibrium, that means 0.2 moles of calcium carbonate must be consumed, right? So number of moles of CaCO3 consumed will be 0.2. Number of moles of CaCO3 left. Total it was 0.5, 0.2 consumed, it is 0.3. Then what is the percentage of CaCO3 left? That is 0.2 by 0.5 into 100, right? 0.3 by 0.5 into 100, so I will get 60%. Okay, option number C here. Clear? Next is, let us do some question here. For the reaction A plus B giving you C plus D, the equilibrium constant cannot be disturbed by. If you do addition of A, equilibrium will be definitely disturbed. Addition of D, equilibrium will be disturbed. Increasing of pressure. I told you pressure will have no effect if the number of reactants and the number of products, number of moles on the reactant side and on the product side are equal, right? Here you see 2, here also you see 2. So that is why there is no change, there will be no effect on the equilibrium if you are increasing the pressure. Option number C will be the correct answer here. Next, the conjugate base of NH3, right? So if you remember, let us write again. If you want to find conjugate acid, right, then what you have to do? Add H plus. And if you want to find conjugate base, right, then remove H plus, right? So you need to find conjugate base of NH3. Conjugate base of NH3 will be remove one H plus, so you will become NH2 minus. Okay. Once again, if this is conjugate base of something, right, so this one is behaving on an acid, it will remove one H plus, so you will get NH2 minus. Okay. Next, which of the following is the strongest base? Okay, so if you see strongest base, right? So now what are these all things like HCl, H2O, CH3OH and CH3COOH, right? These are the acids, and from these acids if you remove this H plus we get this one, right? These are the acids, and this after removing H plus I am getting this one, so these are the conjugate bases. So if you want to find the strongest base, right, the strongest base will be your OH minus, because water is the weakest acid here, right? So here one thing is there, if acid is weak, okay, then conjugate base will be stronger. Okay, now if you see in all these cases, okay, HCl is a strong acid, this comparing all this, water is the weakest acid, okay, so its conjugate base will be the strongest one, okay, so that is why option number B is the correct answer here. Next, acidity of BF3 can be explained on which of the following concepts? So BF3 means it is on the basis of Lewis concept, right? So Arrhenius no, Bronsted no, Lewis concept, that is option number C here, okay. Next one is, okay, one more option is there, Bronsted, Lowry as well as Lewis concept. No, it is only Lewis concept, okay. Next, question number 5. In the reaction, if the concentration of OH minus is decreased by 1/4 times, then the equilibrium concentration of Fe3 plus will increase by. Okay, so now if you see, if I write the equilibrium reaction for this one, K equilibrium will be the concentration of the product, that means OH minus to the power of 3, and then I have Fe3 plus, right? Now what is it saying, that if you are decreasing the concentration of OH minus by 1/4 times, right? So it will become 1/4 of OH minus to the power of 3, and if this one is decreasing, this must increase to make this one as constant, right? So x times Fe3 plus will increase, right? Now it is 1/4 of 3, that means 16, 4 4s are 16, 64 times, 1/64 times of OH minus, right, and this one should be increased by 64 times, okay, so that this 64 get cancelled and we get the same value again, right? So it should be increased by 64 times. Next, question number 6. Which of the following species can act both as an acid and a base? Okay, so if you see, if it is behaving as an acid, it should release H plus. If it is behaving as a base, it should accept H plus, right? SO4 2 minus, it can only accept H plus. It doesn't have any H plus to donate. So if it is accepting H plus, it can behave only as a base. PO4 3 minus can also only accept H plus and it can behave as a base. OH minus can also accept H plus and it will behave as a base. But if you see HSO4 minus, okay, HSO4 minus can accept H plus to give you what? H2SO4. So at this time it is behaving as a base. Now at the same time this one also donate H plus. If it donate H plus, what I'll get? SO4 2 minus, right? And if it is donating H plus, it will behave as an acid. So it can behave both as acid and a base. That is option number B here. Okay. Next, this is the homework question. Which of the following is conjugate acid of SO4 2 minus? So if you remember, if you want to find conjugate acid, what you need to do, right? I told you, if you are finding conjugate acid, that means this one is behaving as a base. It should accept H plus, right? For conjugate acid, it is addition of H plus, and for conjugate base, it is removal of H plus, right? Okay. Yeah, that is all in this lecture, students. This was very important lecture, and in the next lecture we will be discussing about ionization and all. So please subscribe the channel for more such videos, and thank you for watching. Remember, your target PU2 date sheets are already out, so it's really now time to get serious about your preparation. Okay, so all the very best, champions, and see you soon in the next class.